Alright, let us have deflection of simple beam with overhang, and let's have the second part of this solved problem. Alright, so I hope you watched the first part of this video wherein we are required to solve for the slope and the deflection at points B and E, assuming EI is constant. So I will assume that you have watched the first part of this video. So in that part, we were able to solve the deflection and the slope at B. So in this part, let us solve the other requirement, which is the deflection and the slope at E. And also, we will solve it. Normally, we use the moment diagram by parts. So we will use, instead of moment diagram, we will use moment equation by parts. Ayan. So that's a new technique, you know. Of course, we will be using our programmable calculator so to integrate the equation. So fortunately, we are allowed to use that model. So no problem, and it will be a lot easier. So because you are no longer required to draw figures that very, I could say, there are lots of limitations. No? Anyway, let's look at that. Okay, so let's continue on. So we will now have the deflection and the slope at point E. Okay. Okay, so let's have this now. So we will solve for TEA. So we need the moment diagram, the deviation of point E from the tangent through A. So we need the moment diagram of the whole beam from A to E. So let's draw the moment diagram at E. Okay, moment diagram at E. So let's start with this reaction. So this will be a first degree curve, triangular in shape. So this is 232 times 3. So the moment here, this is 3 meters. So the moment here is 696. So the area of this is 1/2 3 times 696. So that's 1044. And we need to measure the centroid of that from E. So that is it. So that is 1/3 of 3. So that's 1 meter. Okay, that is for this reaction here. And let's have the 110. So the diagram for the 110, the moment diagram at E, that will be 110 times 12. So that's 1,320. So the area of this big diagram is 1/2 12 times 1,320. So that's 7,920. The centroid is 1/3 of 12 from here. So that's 4 meters. 12 over 3. Next, the uniform load. Alright, so the uniform load is second degree curve, spandrel of a beam, spandrel of a parabola. And the moment here will be 18 times 12 times 6. That's negative. So that will be 1,296. Okay, you can check it yourself. No? That's the moment caused by this uniform load at E. 18 times 12, that's the total load, times the moment arm from E will be half of 12. So times 6. Okay, so the area of this is equal to 1/3 12 times 1,296. So that's negative 5184. And the centroid is 1/4 of 12. So that will be 3 meters. Next, the applied couple. So that's negative 270, and that is uniform. So that is very simple. That's purely rectangular. 9 meters ang length dito. 3, 2, at saka 4. So that's 9. And the magnitude is negative 270. Again, why negative? Because that moment is bending down at E. Causes a downward bending at E. Okay, concave down. Okay, so the area here is 9 times negative 270. So that's negative 2,430. The centroid of this from E is 1/2 of 9. So that's 4.5. Alright, and the concentrated load of 90 from E, that will be 90 times 5. So that's the first degree curve. 90 times 5, that's negative 450. Then the area is 1/2 5 times negative 450. So negative 1,125. And then the centroid is 1/3 of 5 from this side, from E. So okay, so that's 5 over 3. So we can now solve the deviation of point E from the tangent through A. So TEA. So that's equal to the first moment of these areas from E. So starting from here, that will be 1,044 times 1 plus 7,920 times 4, this one, minus, okay, this one, 5,184 times 3, okay, this one here, and then this is negative 2,430 times 4.5, this one, and this is 1,125 times 5 over 3. I hope you can follow that. Then you can now have your TEA as 4,362 over EI. Okay. So this is it from here up to here, but that's not yet the deflection. Okay. The deflection is this one. But actually, we do not know yet if that point will be above the beam or below the beam. So let's just assume it's below the beam. So how will we solve that knowing TEA? Alright, so take note that we already have the theta A. We already got this one. This is the value. We got this in part 1. Please watch the part 1 so that you can follow this one. So how will you solve this one? So this is 12 meters. 12 meters. So this total height from this point to this level is 12 meters times theta A. This one here, from here up to here. I hope that is very clear. Let's use a highlighter so that makita ninyo. That will be from here up. Sorry. That should not be a highlighter. It should not be that. Okay, from here up to here. That one. From here up to here. That is 12 times theta. Alright? 12 times theta. So your delta will be, assuming this is going below, that is below the beam, that will be 12 theta minus 12 theta A minus TEA. This is it. 12 times slope, that will be the drop, minus TBA. Well, if the answer will be positive, so true that your delta E is below. If the answer becomes negative, meaning your delta E must be above the beam. So that's very easy because of this orientation here. The assumption that we have made. So you will have the answer 12 theta A. Theta A is this one minus theta EA. So this will give you, alright, so positive 257 kilonewton meter cube divided by EI. So we got a positive sign, meaning this is correct. It is really below that beam. Because if that will be negative, so the magnitude will be correct, but meaning wrong, our assumption is wrong, it should be on top of the beam. Okay? So that's it. So that's the reflection at E. Okay, next, the rotation at E. What will be the rotation at E? Okay, how will you do that? The rotation at E. Of course, we should start with the tangent. The tangent of to the elastic curve at E is that one. Alright? Now, what we can solve is the angle between this tangent and this tangent. We can solve that. And we call that T or theta AE. Theta AE. The change in slope between the tangent lines drawn through A and E. Did you get this? Okay. So, and that can be solved easily because we have the areas here. Alright, so after that, how will we solve for theta E? Now, theta E is the angle of this tangent from the horizontal. This is the angle, theta E. Now, we already have theta A. Take note that this theta A is the angle from here up to here. This is your theta A. Alright? So, your theta E will be this one. And that will be theta A minus theta AE. That's clear. Alright? So, what is left for us to solve now is the theta AE. So, theta AE is equal to the 1 over EI times the area of the moment diagram between A and E. So, all the areas there. So, we just substitute, okay? So, just follow this. 1 over EI, so what? That is 1,044 plus 7,920 minus 5,184 minus 2,320 and minus 1,125. No more moment arm. We are only after for the area. Then we have the angle. So, 225 kilonewton meter squared over EI. So, notice that the answer is positive, meaning the slope is increased. From negative to a negative pa rin, but it is increasing. It did increase. Alright, so you have your theta AE. Then we can now solve for theta E. Substitute this here. Your theta A was already known. That's in part 1. Okay, so that's 384.917 over EI minus theta AE. So theta E, this one. So theta A minus theta AE. Okay, so the answer is 159.917 kilonewton meter squared over EI. Alright, so that's the slope of the elastic curve at E. Okay, now, I know even just the same with as before, no? Dito yung mahirap. Ito yung mabusisi, no? Okay, most students had a hard time doing this. Okay? Now, we can get rid of this with the use of technology now, our programmable calculator, which can integrate easily for us. We can get rid of this diagram. But what we will do, instead of moment diagram by parts, moment equation by parts. Okay? By parts. Load by load. Okay, I hope you can catch up with this. I will show you this. Alright, now, let us make the equation of the moment. Every loading, we will make an equation of that for the entire beam if necessary. Okay, for example, if I will start from A, okay, notice that if I will move from A going to E, this load, the reaction at A, which is 110, and the uniform load is always included, correct? Okay, anywhere am I, anywhere from A to E, the 110 and the 18 is included. Okay, let's make an equation of moment for that. So the moment at any point in the beam, so my X here is reckoned from here. So the moment of these two loads from any point, I'm just putting it here, will be 110 times X minus 18 times X over 2. This one, 110 is the reaction times X minus 18, the load, times X over 2, or negative 9X squared. Alright. This will take care of the 110 and the uniform load over the entire span. Okay. Next, how about the 270? For the 270, I will just start from B. Okay? Okay, it will be this will be included only if the point is B to from points B to E. Okay? So reckoning from B, the moment of that is constant. That's negative 270. I'll call it MB. Alright, MBX. Okay? Negative 270, no more moment arm. So this is only for that couple. Okay? I hope you're following. And then let's make an equation for the 90. For the 90, starting from C, it's only applicable from C to E. Alright? So that will be at any point from C, that will be negative 90 times X, the moment arm. Imagine this is the 90 here, going in this direction. 90 negative 90 times X. Okay, that's it. And your 232, it will only be seen from D to E. Okay, so if this is the X, so at any point X from D, that will be positive 232 times X. I hope that's very easy. You can understand. I'm sure you can understand this one. So this will replace our moment diagram by parts. Take note. But of course, this will include integration. But don't worry, we will not integrate it ourselves. We will let the calculator do it. I will show you how to do it with the calculator. Alright, so finally, let's check. This is the value of TDA that we got earlier. Alright, TDA. In part 1, we got this value. Let's check if we can get the same value. So look here. TDA. So from D to A tayo. So the moment diagram from D to A lang. And then the moment arm must be measured from D. Take note, moment, area. This is it, right? The second theorem. 1 over EI times the area of the moment diagram times the barred X from D. Take note, from D. Okay, so I hope you can get this one. I will explain this one by one. 1 over EI. Okay, look here. This one here, 110 minus 9X is this one. Okay? Don't look at that yet. Okay, I will explain this one by one. Oh, okay, we will do the yellow first. 110. This moment arm is, okay, this is from D, no? Ito yung X. So the moment arm from the tip of this arrow up to that, and that will be 9 minus x. Because from here to here is 9. From here to here. We take note, we are getting the moment at D. Part x from D. So that's why that's 9 minus x. I hope you get that. Okay, next. Plus. Okay, negative 270 is that one. So, okay. By the way, the limit, sorry. The limit of this is only from, applicable lang, because we are only interested up to D. So that will be from here, from A, up to D. From 0 to 9. Okay, let's go to this. So that's 270, that's the moment, no problem. So what's that moment arm? That's the moment arm from D up to this point. And that will be 6 because from here to here is 6. From here, from this level to here is 6. That will be 6 minus x. Okay? And the limit will be from here, that is x equals 0. Take note, my x location was moved, right? From 0 up to 6 only. From 0 to 6 is the limit because I have this as my origin na. You can have this as your origin, but it is much convenient to have your origin where the load is applied. So in this case, it will be here. Next, this one. Look. Plus 90. So this, we will not include this anymore. No? Take note, we will only be getting the area or the equation from A to D only. So this will now be the last. Okay? Integral the moment. I think that's very clear. But that's what. This is it. Okay. Why is this the moment arm? Alright, because that will be from D up to the point here, which is x from here. The distance is x. So D, okay, that will be 2 minus x. And the limit will be from here, from 0 up to 2. From 0 to 2. Okay? So you can integrate this one by one using your calculator, or your calculator is very smart. Pwede mo integrate yan sabay. Okay? I will show you how. Okay? So mode 1. Okay, computation tayo. So, okay, let's start. From 0 to 9, integral of 110x alpha x and then minus 9x squared. I hope you know how to do this. Okay? And then the moment arm is 9 minus x. Shift x, close, and then the limit is from 0 to 9. Okay. Okay, let's add the other integration. Plus the second term. Integral. Or we can take out the 270. So minus 270. Okay? Times the integral of. So what will be left there is 6 minus x only, right? I hope you can follow this one. Okay. Sorry. Parenthesis. 6 minus x. Okay. Limit is from 0 to 6. Okay. And then plus. Okay. Okay. Negative 90. I will put this out. Negative 90 times the integral of x. Okay. Shift x. Alpha x times moment arm is 2 minus alpha x. Close in parentheses. Okay, I hope this is clear. This is correct. Okay, from 0 to 2. Okay, then equals. Alright. Okay, let's check. Okay, that's 3464.25. That's very, very equal to this. Okay. That's equal to that. I hope you got this already. So, many would say the integration is difficult. Yes, it's a bit tedious, but with the use of this program or calculator, that will be easy. I hope you will start to like integral, especially in theory. No? So, this is very useful. Okay. So, I would like to check the rest. Okay, how about TBA? Just to show you. Maybe I will not show na lang the calculator or it depends. Okay. Let's try TBA. Let's try to solve this one. TBA. So you will only be needing the point from B to A. So meaning, we will only be using this part. No need of this anymore. So you can imagine this as the by parts. The one that you have. Instead of moment diagram by parts, moment equation by loading, by parts. Na? Bago yan. Na? Okay. So ako ang gumawa niyan. Okay, sige, let's try. TBA. So, only this one here. only this one. And then we will only be using from A to B. So from 0 to 3 ang limit natin. Ha? From 0 to 3. Okay, so look at this. 1 over EI times, look, integral of this one and the moment arm, okay, this is your x, ha? Okay, this is just exaggeration. Your x can be present anywhere. So imagine this is your x. I will draw it here. Imagine this is your x. So this is the moment arm. Alright, that is 3 minus x. Alright? And that's it. That's all we need. That's all we need. Okay, I will use the calculator para maklaro natin. Ha? Okay, integral of 110x minus 9x squared times 3 minus x, close parenthesis, from 0 to 3. From 0 up to 3, that's it. No more, no less. And that will be, okay, 434 point. Okay, the same value as this. 434.25. Okay. Very nice. Okay, so I will not check anymore the deflection, just the deviation, just showing you how the other option in finding the deviation instead of using or drawing the moment diagram by parts. Okay, and let's have the last. Okay, this one, the rotation. The rotation AI. This one. TAE. I mean, theta AE. Sorry. TEA muna. TEA. So, TEA, at it will now be the whole span from A to E. Okay, so it will look like this. Look at that. I will not use the calculator anymore. So, I'll just explain you how the equation become one. No? So, the first is this one. The moment arm is 12 minus x. Why 12 minus x? Because this is from E. 12 meters minus x. Okay. The limit will be from 0 to 12. Alright. Okay, how about this? That's 270. No problem. Why 9 minus x? Because from B to E, that's 9. 9 minus x. And the limit will be from B up to E only. From 0 to 9. Okay, next, the 90. Okay, why 5 minus x? Because that is from E to C is 5. From E to the 90 is 5. So that will be 5 minus x. And why the limit? 0 to 5. Because from C, 0 up to 5. And this is 232. Alright, this is it. It will now be included. So 232 times x. Okay, that one. And the moment arm will be 3 minus x. Okay, from 0 up to 3 only. Alright, I will not use my calculator anymore. Just check it yourself. That's the value and exactly the same as this. Okay? And the rotation. Finally. Ito, rotation AE. That will be the whole span, A to E. Okay, that's simple. Actually, we can copy what we had before. We can copy this one, less the moment arms. Tanggalin natin yung moment arms. Yun lang. No? You can edit your equation before and then just remove the moment arms. No? Sorry, this is error. This should not be included. Sorry. Oops, excuse me. I was not able to delete this one. Okay? Okay, ganun na lang. Na? So, that's it. Okay. So, without the moment arm only. Alright? The same limits, the same lahat. Okay? 225 over EI. Okay, so I hope you learned a lot from this video. Okay, abangan nyo yung ating part 3. We will solve this in different method pa. Okay, I hope you learned a lot, and please don't forget to subscribe to our YouTube channel and hit the bell icon so that you'll be notified every time meron tayo mga bagong videos. Thank you so much for watching.